Like I said in my first video, we said we are going to look at the syllabus of a JUPEP. So this is JUPEP syllabus for direct entry candidates. It encompasses both O-level and A-level exams in Nigeria. So in our organic chemistry 2, we are going to look at structure and bonding in organic compounds, which simply means our second class should be hybridization. So we are looking at hybridization in this class. Now, number one, what is hybridization? Hybrid is like an offspring. It's like an offspring. Hybrid is an offspring. It's like a product. So that means hybridization is a mixture of two things. Now, but what are we mixing in hybridization? We are mixing orbitals. So simply means hybridization is the mixture of two or more orbitals. Hybridization is the mixture of two or more orbitals. It means if you have s orbital and you have p orbital, you can mix the two together to give you sp. That is the meaning of hybridization. We are still coming back to it. Then tetravalency. Tetravalency. What's the meaning of tetra? Tetra means four. Tetra means four. And valency means outermost electrons in a shell. Outermost electrons in a shell. So that means tetravalency is all about four electrons in the outermost shell of carbon atom. So tetravalency of carbon means four valence electron in the outermost shell of a carbon atom. Now, having defined hybridization and tetravalency, then the next thing is, how do we get hybridization in carbon? Number one point that you must know here is that for carbon to function properly, it must contain four electrons that are unpaired. These four electrons must be unpaired. What do I mean by unpaired? Unpaired. Unpaired. If I have this is pair. If I have this is unpair. Pair means two, unpair means one. Pair means two, unpair means one. Now, how do we form hybridization of carbon? To do that, we must look at the electronic structure of carbon atoms. Carbon atom is found in group 4. Carbon atom is found in group 4. That means the valence electron of carbon atom is 4. Since it is found in group 4, then the valence electron must be 4. Now, if you go to your periodic table, starting from hydrogen, helium, lithium, beryllium, boron, carbon. So the atomic number of carbon is 6. That means the electrons in carbon must also be 6. If that is the case, then the electronic configuration of carbon can be written as 1s2, 2s2, and 2p2. We will revisit this later. How I got 1s2, how I got 2s2, and how I got 2p2, we will revisit that later. Now, if this is the electronic configuration of carbon, let us put it in a sketchy manner so that we have adequate understanding. All right. If we want to put this correctly, then we have 1s2 here, or let me don't put these two there. So we have this, we have this. Then we have this. This is 2s, and we have this. 1, 2. So this is what we have. This is the ground state electronic configuration of carbon atom. This is the ground state of electronic configuration of carbon atom. So if this is the ground state, and we now need to hybridize it, when we hybridize it, there must be a kind of 4 electrons. Those 4 electrons must be unpaired, as I said earlier. To make this thing possible, what we are going to have is that electron from 2s2 will have to move. This electron will have to move to this place. When that happens, we discover that 1 electron remains here. We now have 3 electrons here. To redraw this thing perfectly, we then have so this is 1s. We don't have 2s again. This is 2p. We don't have 2s again. We don't have 2p again. Why? Since we have removed an electron from here, to this place, we forget about this. Since we have already brought electron to this place as well, we forget about this. We give them another name. 1 electron is coming from S to P. That means we have mixed S and P. We have mixed S and P. So we are having now SP, hybridized orbital. SP, hybridized orbital. All right. Now, so here we have the remaining 1 electron here. We have it. There is 1 here already. There is also 1 here already. The one that promotes itself from here to here. Now, this one is called 1s, right? This place is 2s, but there is no 2s again. This place is 2p, but there is no 2p again. As a result of this, it means that we can now have sp now. sp. Since the contribution of the p is 2 electrons, and the contribution of the s is 1 electron, we call it sp3. So each of this orbital here is now sp3. This is also sp3. This is also sp3. And this is also sp3. So for carbon atom to bond to 4 hydrogen, this is hydrogen here, this is hydrogen here, this is hydrogen here, this is hydrogen here. It means in the covalent bond here, we have sp3 electron being contributed by carbon, and we have only 1 electron, which is from S of hydrogen. So we have sp3 S bond here. sp3, S bond here. The same thing here, the same thing here, the same thing here. So this is just what we need to know about hybridization. We have explained that hybridization simply means mixture of two orbitals to produce an hybrid orbital of another character. Then tetravalency means, tetra means 4, valency means outermost electrons. So tetravalency simply means 4 electrons in the outermost shell outermost shell of carbon atom. For carbon atom to bond to 4 hydrogen atoms, we must have 4 unpaired electrons. And that is exactly what we have explained here. That is what we need to do on tetravalency and the hybridization of carbon. In my next class, we are going to look at the structure of methane, the structure of ethane, and the structure of ethene, and the structure of ethane. In those structures, we will be able to talk about the kind of angle that is between these two bonds in alkanes, and in alkynes. So if you have watched this video and you find it useful for you, please don't forget to either call or WhatsApp me on 080 36 16 7723. Don't also forget to like our video. My prof, you can search for my prof tutor. My prof tutor. Thank you.